This morning at 4:10 Universal Time, Atlas revealed something nobody expected. 7 distinct jets shooting out in multiple directions like a cosmic octopus reaching out in every direction. And what these images show could prove Atlas is natural or artificial. It could go either way. Let me show you what we're seeing and why this is massive. Astronomers captured stacked images of Atlas at 29 degrees separation from the Sun. 24 exposures in green filter, 2 in red, 2 in blue. What they found is extraordinary. A massive glowing halo extending 500,000 kilometers into space, 5 arc minutes across. And cutting through that halo, at least 7 distinct jets. Some of these jets are anti-tails, material shooting toward the Sun, against radiation pressure, defying what comets normally do. This is complex structure. This is active outgassing. This is exactly what we've been looking for since the non-gravitational acceleration was detected at perihelion. Here's why this matters. Remember the test? We needed to see massive mass loss if Atlas's acceleration is natural. We calculated it would need to lose 1/6 of its mass, 5.5 billion tons of material, to produce that acceleration through normal outgassing. And now we're seeing it. 7 jets, material streaming in multiple directions. A debris cloud representing a substantial fraction of Atlas's initial mass. Case closed, natural comet, mystery solved, right? Not so fast. Here's where it gets complicated. When you have jets pointing in many different directions, the math changes. Each jet carries momentum, but they're not all pushing in the same direction. Some cancel each other out. The net acceleration, the actual push that moves the object, only comes from the imbalance between all those jets. Avi Loeb calculated what this means. If these 7 jets are natural outgassing, and they're pointing everywhere, then Atlas would need to eject much more than the original 10 to 20% of its mass. Way more. Because only a fraction of that ejected mass carries excess momentum in the preferred direction we measured. In other words, to get the acceleration we detected through random multi-directional jets, you need massive mass loss. A substantial fraction of the entire object. That's possible. Comets can be fragile. They can shed enormous amounts of material near perihelion. We might be watching Atlas disintegrate in slow motion, losing huge portions of its mass as it heats up and sublimates violently. But here's the other possibility, and this is crucial. Technological thrusters could give Atlas the exact same acceleration with much less mass ejected at much higher speed. If you're designing a propulsion system, you don't want random jets in all directions. You want focused, directed thrust, high-velocity exhaust, efficient momentum transfer. But what if you have multiple thrusters? What if you're making course corrections in different directions? What if some thrusters are firing to adjust trajectory while others compensate for rotation? Then you'd see exactly this. Multiple jets, complex structure, material streaming in various directions, but with specific patterns, not random sublimation from ice pockets, controlled burns from thruster arrays. The images show both possibilities. They show massive outgassing consistent with a natural comet losing substantial mass. And they show complex directional jets consistent with multiple propulsion systems firing in coordinated patterns. We're seeing the evidence. We're seeing the jets. We're seeing the 500,000 kilometer halo of material. But we still can't answer the fundamental question. Are these jets coming from pockets of ice on the surface of a natural cometary nucleus, sublimating randomly as the object rotates and different areas face the Sun? Or are they coming from a set of jet thrusters used for navigation of a spacecraft, firing in specific directions to make precise course corrections? We don't know. The observations were challenging. Atlas was only 7 to 10 degrees above the horizon. Twilight interfered. There was bright moonlight. These weren't ideal conditions. but they captured something extraordinary. For now, as Avi Loeb says, let us enjoy the view. After all, a picture is worth 1,000 words, and these pictures are telling us a story. They're showing us an interstellar object doing something remarkable. Whether it's natural or artificial, whether it's ice sublimation or rocket propulsion, we're witnessing something unprecedented. December 19th, when Atlas makes its closest approach to Earth, will give us better observations, clearer images, more precise measurements. Hubble will see details these ground telescopes couldn't capture. Webb will measure thermal signatures that reveal whether these jets are cold ice sublimation or hot exhaust plumes. Until then, we have these images. 7 jets shooting out in multiple directions, a cosmic octopus reaching through 500,000 kilometers of space, an interstellar visitor showing us it's active, it's dynamic, and it's not done surprising us. 7 jets. One question: are they ice pockets or thrusters? The data is coming, the observations continue, and soon, very soon, we'll have our answer.